Hello, today is Friday, September 20th, 2019. My name is Daniel Mullaney, and behind the camera is Caitlin Yates. Today we are filming a video source inspection for a refurbished Mini Brute MB-80 tabletop furnace system. So first what we're going to do is there's not too much to demonstrate when source inspecting a system like this. We're not actually going to be running wafers through it. We're not actually going to be, calibrating it to your settings when it arrives at the fab. So what we're going to do is just kind of review the fact that it is on, that it is meeting its set point, that it is stabilizing, and we're going to review all the kind of components as we go around. So first thing I'm going to do is I'm going to turn off the light so you can see that the system is on. It has been stabilizing around 680 Celsius basically all day now. We're in the afternoon and it's been stabilizing all day. Just to verify that it will hold temperature, and everything's been working great. Now taking a look back here, what we have is right here we have an inlet for a chiller. This is going to be important for cooling your system down, especially if you're going to be running high temp over 600 or 700. If you're getting up towards 1,000 Celsius, then you're definitely going to want to have a chiller hooked up to this. Here we have your pressure regulators for the nitrogen inlet. See that you're turning down the nitrogen, turning it up, and the oxygen inlet, demonstrating they both work right there. Here we have the flow meters for each. Here we have the nitrogen, so you can turn it up or down right there on the flow. Same with the oxygen. Here we have the inlets for the two gases. We have oxygen and nitrogen. Right now we're just teeing off to nitrogen because we don't have an oxygen gas that we can provide. So we're just going to be using a T right here for the flow. We have the outlet for the mixed gases right here. So here you have the nitrogen and oxygen mixed together. I can feel them flowing out. So the gases come in and they come out mixed. What you'll do is you'll have a tube that comes around to the back of the system. Typically, you can also introduce gas from the front, but it'll be introduced through the back through a ball joint, and that's how it'll flow through the chamber for any of your oxidation process. Here we have a switch for a fan, or for the fans. There's 3 fans in here, and they're critical to keep on while processing. The fans are going to circulate air and prevent overheating in the entire system. So then here we have the 208 volt single phase power that we're hooking up. That's actually provided via this transformer right here. So we'll be coming around the system now. As you can see, we have it labeled for the electrical hazards and for the safety of the system. Now we're coming onto the back. So inside this box, this actually isn't an attribute that's typical of, or that's on a normal configuration for it. This was added, but it is a convenient feature. It protects the back of the furnace tube and the ball joint, and it also has an area or a hookup for an exhaust on the side right there. There's actually a little panel in there that was knocked over. It's too hot for me to readjust at this point, but that's where you can either close it off or hook up an exhaust to this back area. So now let's go over the different items on the control panel. So as you can see, this is a really simple setup for the controls. We'll start here. Right here we have 2 needles on the gauge. We have one that shows the current temperature of the chamber. This is the approximate center of the chamber. Taking a look at it, we're at, like I said, 680 degrees. This other needle to the right, as you can see I'm moving it right now, that's the overtemp set point. So I'm going to turn the overtemp set point beneath our current set point so you can see what happens. Watch this breaker too. So now we've hit an overtemp condition. In that circumstance, to reset it, you're going to hold reset, and then you're going to set the set point higher. That'll turn it off, but if this actually does flip, you're either going to be too hot, which you'll need to address what happened with the system, or this needle was adjusted, or you have some kind of valve failure, gauge failure, but this is the overtemp configuration for the system. So I put it back to about 1,000. What you do is you'll turn the power back on. This switch right here is going to be the power for the control panel, all the control right here, so we're going to leave that on. And now we're going to come over here to these gauges. This is the way that you're going to calibrate the temperature setting for your MB-80. So this is the back, the center, and the front heating assembly. When you calibrate this on site, you're going to want to use a long a long probe that you're going to put through the tube, and then you're going to calibrate each one of these one at a time. Actually, so this one just turned on. That means that it's falling off of the deviation and it needs to send power or turn off power in order to bring that back into the set point. So I can make this one do it too, or make this gauge fail as well, or not fail, but show it needs adjusting. So I just raised it. So now it's saying, I need to send more power because I'm outside of my set point on the deviation. We're going to reduce that now. And so this one turned on because, so now I adjusted it down, but it was already sending power before, so now it's saying, I'm a little off on the deviation, I need an adjustment. So these lights will turn on as the system runs to meet those set points. What I'll probably do is, like, if say I were to turn this up, now it's closer to the set point, that one's closer to the set point. So really you'll be adjusting these controls to adjust the amount of power that's sent to the chamber. This is approximately the temperature set point, but it's not true accurate. What you're really going to want to do is be measuring inside of the furnace tube and making adjustments here until you hit the temperature pattern that you want your furnace to have. So that's really all there is to this tool. It's a pretty straightforward tool. You're really going to be introducing oxygen and nitrogen. You're going to be calibrating your heating elements. You're going to be setting an over temp. And then apart from that, you're really just going to be introducing your product into the chamber. You're going to be doing the oxidation process that you want to achieve for the amount of time that you want, and then you're going to remove afterwards. So all in all, it's a pretty straightforward tabletop process. I want to thank you for taking the time to review our brief video source inspection for today. Again, my name is Daniel, and behind the camera is Caitlin. And if you have any more questions about this, please get in contact with us. You can visit our website at www.sitecprocess.com. That's spelled S-I-T-E-K. Or you can give us a call at 916-797-9000. And to reach me directly, please dial extension 2201. Thank you, and have a great day.